equation of the normal plane and the osculating plane. For r of t, it's equal to cosine t, sine t, and ln of cosine t at 1, 0, 0. So to start off, we're first going to take the derivative of r, which the derivative of cosine is negative sine. Derivative of sine is cosine. And we have a chain rule here, and it ends up being 1 over cosine t times negative sine t, which we can simplify into negative sine t cosine t negative tangent t. From here, we're going to find the magnitude, since we need it to calculate the tangent plane. So we'll have negative sine t squared, which becomes positive, plus cosine t squared minus tangent squared, which becomes positive. With our identities, we can go ahead and sum in a 1, since we know that cosine squared plus sine squared is 1. End up having 1 square root of 1 plus tangent squared, which we know can be simplified into secant squared, which once the square root is taken just becomes secant t. So that's our magnitude. So now we come in and we find t, which is just the first derivative over its magnitude. And we just simply go ahead and plug it in. 1 negative sine t cosine t minus tangent t all over secant. And since secant is just 1 over cosine, we go ahead and just flip cosine, 1 over cosine, and everything's multiplied by cosine. So we end up getting sine t times cosine t cosine squared t and negative sine t as our answer. We can go ahead and plug in values for 1, 0, 0 to figure out our equation. So once we plug it in, we see that we end up getting 1 times 0, 1 squared, and 0, which ultimately leads to 0, 1, 0, which equals j. Now, from here you can simply say that, okay, so we can see where this is going, and we can say that the answer, that the equation of this line is just y equals 0. Now we're just going to go ahead and finish off the osculating plane. So the osculating plane is the normal and the binomial vectors. So we have the tangent. Now we need to find the normal and then cross those two. So we're just going to go ahead and take the derivative of our t tangent that we had here. Go ahead and section this off. So we have t derivative, which becomes, so we have a negative sine times cosine, we have a product rule here, and it ends up being negative cosine squared t plus sine squared t, negative 2 sine t cosine t, negative cosine t for the derivative. Let me just clean it up a bit. Alright, and so now we can simplify this into just negative cosine squared 2t, not squared t, 2t negative sine 2t and minus cosine t. Again, we need to find the magnitude, so we're going to go ahead and take the square root of this. This negative becomes positive cosine 2t plus sine, negative sign, which becomes a positive 2 squared 2t plus a negative becoming a positive. We know again from our identities that we can substitute cosine squared and sine squared with a 1, and that leaves us with 1 plus cosine squared t in the square root. So now our normal is just derivative of t over the magnitude of the derivative, which equals 1 plus cosine squared t times negative cosine 2t minus sine 2t minus cosine t. To recap, that nt just equals the derivative of t over the magnitude of the derivative, which is just 1 plus cosine squared t square rooted times negative cosine 2t minus sine 2t minus cosine. So from here we have t and we have n, so we're going to go ahead and cross them. So to make our lives easier, we're going to go ahead and plug in t is equal to 0 for both of them. So recall that we have the tangent vector is negative sine t cosine squared t and negative sine t. And at t equals 0, we get the vector 0, 1, and 0. Now plugging in t is equal to 0 for n, we get square root 1 over the square root of 2 times 1, negative 1, 0, negative 1. We can go ahead and cross this to get v, which is our binomial, which will give us our osculating plane. So we have I cross j, and we have 0, 1, 0, negative 1, 0, negative 1. Go ahead and do the cross product, and we end up getting negative 1, 0, 1 times 1 over the square root of 2. Now, plugging in with our normal plane equations, we have our vector times r minus r naught. We end up getting the equation u is minus c minus x plus 1 equals 0. And those are our two equations for those